Three, two. Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and WhiteSource. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting presentation ahead, but first I have a couple of housekeeping notes. First off, today's session is being recorded, so if you miss any of our discussion, the on-demand recording will be made available shortly after we conclude today's webinar. If you have any questions for our speakers today, we want you to go ahead and drop those into the Q&A tab. And if you have any other general comments or you want to let us know from where you're tuning in, we want you to direct those comments to the chat tab. We will have one poll towards the end of our program today, so we highly encourage your participation in that. And we also have some handouts today that are available for download to help enhance your experience today. So go ahead and download those at your leisure. Finally, at the conclusion of our webinar, we will have a drawing for 4 $25 Amazon gift cards, so stick around. So our topic today is how to leverage defense in depth and prepare for the next Log4j. And I'm joined by Aaron Edelman, Partner Solutions Architect at AWS, and Jack Marcel, Senior Director of Product Marketing at WhiteSource. Aaron, Jack, thank you both so much for being here with me today. I'm going to give the floor over to you.
Thank you, Cody. Hello, everyone. Today, Aaron and I are going to be talking really about planning, about how you can really be prepared to handle the next Log4j, because there's going to be another event like Log4j. We're going to be talking about preparation, about software resiliency, and about how you can use all of your security controls when you need them the most. Now, frankly, this is a very ambitious webinar. We're going to cover a lot of territory, and we hope that you come away with some good ideas. Now, we thought that it would be best to use Log4j as an example throughout the next hour. We're going to take a look back at what Log4j was all about. We're going to look at a case study of a company that responded to Log4j quickly and easily because they were well prepared. They were resilient. And then the majority of our time, as shown here, we're going to talk about best practices, about the game plan that you need, first to prepare in advance, and then to react with compensating controls on the network, with remediation of software vulnerabilities, and with monitoring your environment to see if possibly an attacker was successful in penetrating your defensive layers. So let's dive in. What was Log4j all about? Now, for some of you, this is old news, but for the rest of you, I'm going to bring you up to speed. Apache Log4j is a logging utility. It's provided by the Apache Software Foundation. It's open source software. It's very widely used. It's actually present on the Mars Pathfinder rover. It's used by the Minecraft game. And I'm going to bet that at least one of the applications that you've used over the past week has probably used or is using Log4j. Well, so far so good, but unfortunately, a vulnerability was discovered and was announced on December 10th of 2021. And that vulnerability enabled arbitrary remote code execution, and it was rated with the maximum severity score of 10. And everybody saw headlines such as the ones you see right here. Now, if you're an attacker, here is how you would exploit Log4j. It's a 3-step process. First, you post some malicious code to a server that you own. Then you send a text string to an application that's using the vulnerable Log4j library. And the text string tells the Log4j library to download and execute the malicious code that's on your server. And step 3, there is no step 3. It's just that simple. And that's why the vulnerability received the highest possible score of 10. So since Aaron and I are going to be talking about network controls today, I want to go just one level deeper to understand a little more technically how this exploit worked. The attacker is shown on the left and the vulnerable application is shown on the right. Now, Log4j uses something called Java Naming and Directory Interface. I think it is JDNI. And this leverages a number of different network protocols, LDAP being one of them. And LDAP is the interface that attackers just happen to find the easiest to exploit. So this slide shows how the attack works. First, the attacker sends this JDNI command string to the application, like the one shown at the top. And then the vulnerable application makes an outbound call to the attacker's server on the lower left. The server responds by sending malicious code back to the vulnerable application, which then executes the code. Boom, you're compromised. It's that simple.
Thank you for that overview, Jack. I'm curious, what would be a legitimate use case for a JNDI lookup to an LDAP server?
Yeah, thanks, Aaron. Good question. So Log4j is about logging, and it supports a logging capability known as lookup. And lookup is a way to add more contextual information to a log. For example, you can look up the attributes of a Docker container, or you can look up environmental variables. And one of the ways to fetch information is through LDAP. Now, LDAP was not originally designed for logging, but it's a reasonable way to move information from place to place. But unfortunately, once the object has been fetched using LDAP, it can then be manipulated to execute on the server. And that's basically remote code execution right there. On December 10th, there were actually two different types of Log4j exposures that people needed to worry about. There's software that you built yourself, and then there's software that you might have bought from a third party. Now, some of the software that you built yourself contains Log4j and some might not. And to identify which is which, you would use an open source software scanner. And for the software that you purchased from a third party, some might be vulnerable, some might not. And a traditional network scanner is probably your best tool to identify third-party software vulnerabilities. Going back to the left, the software that you built yourself needs to be fixed using your own developers. They're the ones that created it. They need to fix it. Versus the software that you purchase from a third party, you basically need to wait for the developer of that product to issue an update, and then you update your product. Now, the good news here is that for both cases, you have network controls that can block attacks, and we're gonna come back to that. So now that you know what basically Log4j drill looked like, let's take a look at what a good response looked like, a company that was truly resilient. WhiteSource was in close contact with many of our customers during this event, and we had a chance to see, how different companies handled the Log4j exercise. So this is an example of excellent performance. The situation was, this was a large provider of electronic healthcare record software. They had, I think they had 500 software developers spread across 85 different teams around the world. They were responsible for 4,000 different projects. And they had deployed something called software composition analysis from WhiteSource to help them secure their open source software. And this allowed them to scan all 4,000 of their projects every month without breaking a sweat. Now, their challenge, of course, when they first heard on the morning of, or the afternoon of December 10 about this Log4j vulnerability, they wanted to act quickly to secure their applications, which held a lot of sensitive healthcare data for their customers. So as a result of their really good preparation, company's application security team already had full visibility to its entire code base. And that was true even before Log4j was disclosed. So as a result, they were able to put compensating controls in place within 45 minutes, and they were able to fix all their Log4j issues that were under their control within 12 hours. So now for the rest of this webinar, Aaron and I are going to basically share with you best practices that we've seen. And by following these best practices, your company is going to be able to more easily respond when another event happens, kind of like Log4j. We think that there are really 4 things that you can do as part of your game plan. So Aaron, can you briefly walk us through the different parts of the game plan?
Absolutely, Jack. Thank you for that. Yeah, the first is, of course, to prepare in advance, and that entails understanding your environment. So the first thing would be understanding what assets are valuable in your environment, right? Why would an attacker even want to go in there in the first place? So that could be anything from tangible assets, such as personal information or money, any sort of data that's valuable. It could also be intangible. It could be your reputation, your trust, right? Maybe an attacker wants to exploit things in order to hurt trust in the target. Then working backwards from these assets, right? The tangible assets have to exist in various places in your environment. They're in data stores, they're probably being computed in some way. So you start to work backwards from these assets and identify various boundaries within the environment, right? You have various areas where access can be called into question, right? Where only certain IP addresses are allowed and only certain ports. And then once you have a good mapping of your environment, then you can start to look at where you can implement mitigations. And you can implement those mitigations far in advance of an actual incident. So you can start to put network controls in place, web application firewalls. You can also think about the architecture of your application, right? Especially if you're using something like microservices or service mesh. But those mitigations should be in place in advance, because when an incident actually comes up, you're going to make some slight updates to what already exists, and then you're going to focus on remediations, which Jack will be able to talk about in much more depth. That's at the software application level, right? The actual patching. And then finally, once you have all of this in place, you still also want to be monitoring your environment constantly. You want to see, even if you've successfully blocked attacks, you want to know when an attack has been attempted. You want to be able to see any of that activity. And that gives you a good sense of good assurance that those controls are functioning, and it gives you a very good understanding of the overall threat exposure. So let's focus on this first aspect, preparing in advance, because this is definitely something you can do now when things are calm, and then if the storm comes, you will be really ready. So this is a heavily simplified diagram of cloud environments as we have them today, heavily simplified, but there are a few key sections that I want to point out. So one of them is that in order to get into a virtual private cloud, there's got to be some form of interface with the public internet, right? And that could be anything from CloudFront or API Gateway to a load balancer or even AppSync. Either way, you can use web application firewall with any of those services. And this gives you the ability to inspect layer 7 traffic. Likewise, any traffic leaving your VPC, your virtual private cloud, has to go through DNS resolution. And so you can use Route 53. There's a firewall component to it to see any of the outbound traffic leaving your VPC. The next area to look is around the subnets that you have resources running in within your VPC, because each subnet has a network ACL. And this network ACL basically dictates which type of traffic is allowed to which types of ports, right? So you can say from a certain IP address range, from a certain subnet, to very specific ports. Web application would be 80 and 443. But this is important because, as we'll see later, LDAP operates on specific ports. So we can dive into that a little bit later too. And then finally, one thing I'd point out is that all of your resources in AWS in some way interact with IAM. IAM is not just for human identities, it's also for machine identities. And because of this, when a resource is potentially compromised, one of the first things that AWS vulnerability researchers notice is that attackers attempt to enumerate the environment through IAM. So using IMDS version 2 for metadata lookups is a great way to mitigate some of the risk of that enumeration. But good to know that this exists in the first place. Okay. And Jack, back to you.
Yeah, let me just ask, go back to that last slide for just a second.
Sure.
What's the best practice to map all this out in advance to sort of know which applications are in which subnet?
Great question. Yeah, so one way that you can do it, just to know, first of all, which resources exist in your environment, right? Because we have so many different types. We have EC2, S3, compute, storage. So how to get a total inventory? You would actually do it through tag editor, right? So AWS gives you the ability to apply tags to your resources. But even if you haven't done that, you can get a full inventory of all of the cloud resources in your environment by going to tag editor, selecting all regions and all resource types. Then if you want something more specific to see which VPC is it inside, which subnet is it inside, right? To map all of those relationships, you can use AWS config, which will basically audit all of your existing resources. And then you can map that with a tool called Amazon Neptune. It's a way to visualize graphs. So that will give you a very clear indication of how all the resources are grouped. Another option, if you use infrastructure as code, is to use AWS CloudFormation Designer. So this will give you a nice visual, kind of similar to this. And if you use other tools, if you use open source tools or third-party tools, there's many free visualization options out there as well.
Wow, thank you. That's a lot. That's another webinar I want to watch.
Sure. Yeah.
All right. Let's move on. A second part of preparation is knowing what's inside your software. And to do that, you need a software bill of materials. And for several weeks after the Log4j incident, security experts such as Jen Easterly, the director of CISA, were urging customers that didn't yet have a software bill of materials to get one. So what is a software bill of materials, also known as an SBOM? Well, as shown here, it's a formal machine-readable inventory of software components and dependencies. It's information about each component, about the hierarchical relationships. It shows the component names, the version numbers, the risk assessments, the licenses that are associated with each component. And SBOMs are generated by software composition analysis tools. Now, once you know what is in your software by having an SBOM, the next thing you should do to prepare in advance is to proactively keep all your dependencies as up-to-date as possible. Now, here I've got on the screen a hypothetical example using a library called ESAPI. And here you're using version 2.0 that was released in May 2011. And since then, as you can see, there have been a number of updates to that software, a few of which are shown on this slide. Now, suppose one day you wake up and you learn that the package that you have been using, version 2.0, is vulnerable, and you need to upgrade to version 2.2.4.0. Well, this is a potentially difficult update to make. It might break your application because a lot has happened in this library since 2011. And when your dependencies are old, your developers will be faced with this choice: remain vulnerable or upgrade a large number of releases without any adequate ability to test. And this is a real difficult situation for your developers to be in. So a best practice is to keep your dependencies as up-to-date as possible. Now, you can use this by using a dependency automation tool, which scans your software. It discovers what's there. It automatically checks to see if an updated version exists. And it helps you by submitting an automated pull request. Now, an example of such an automation tool is WhiteSource Renovate. It's a free tool. It's called Renovate. You can Google it. You can find more about it on our website. And one of the great things about keeping dependencies up to date is it allows you to proactively avoid vulnerabilities. Now, how is that, you might ask? Well, we've actually done some research into this. We looked at the NPM, one of the most popular platforms in the open source community. And we discovered that actually over 90% of vulnerabilities in NPM packages are fixed before the vulnerability is published on the NVD. And almost 30% of packages were fixed a month or more before the vulnerability was disclosed. So this actually gives developers a large window of opportunity to avoid fire drills like Log4j, all just by practicing good hygiene. So Aaron, what more can be done to prepare in advance?
Sure. So one other step to consider is that after a vulnerability has been exploited, right? As we suggested earlier, the next step for an attacker will be to look deeper into the environment, right? And because oftentimes the assets that are the most valuable are buried a little bit deeper. In either case, when a vulnerability is announced and we're making this rush to patch, another thing we want to consider is whether there has already been an incident that we weren't aware of, right? Or we want to review our logs to see, hey, was there any indication of compromise that happened leading up to this? So one thing that we strongly suggest is to create a runbook. A runbook is basically a premeditated set of steps so that in the moment when things get very exciting, you have a very clear path of what you need to do. And to do that effectively, you need to know things like what types of permissions do people need to have in response to an incident? Who needs to be notified? You also need to think about constraints when executing. So for example, you would not want to disrupt service to other parts of the business if you're trying to control an incident in one specific application. The key part is to have the steps in the right order, right? Because in the moment, you may forget something essential, or there may be a prerequisite for a later step. So you want to have everything lined up in advance so there's not too much thinking in the moment. And then finally, you want to think about escalation. You mentioned earlier dependencies on third parties. So having a process to reach out to other vendors or other customers and say, here's what we're experiencing, here's our current update. Communication here is actually, in many ways, just as important as the technical controls that you have in place. And you can think about escalating in your org as well, making sure that the right people know. So then, now that we have a sense of how to prepare and also what types of runbooks we can have ready to go when there's an actual vulnerability announced, we want to think about some of the controls that we can activate, right? That we can update whenever a new vulnerability comes up. So the very first, I mentioned earlier that there's the option to have a WAF for any traffic entering the VPC. And of course, whenever there's a new vulnerability, we need to consider new rules that need to be put into place. Right? If it's a new vulnerability, we may not have predicted what types of formats it would take, where this text string, for example, is located. So in Log4j's example, this is in a header, right? And it could be a user agent or some other header. So updating the WAF to investigate the header in this particular case would be what we want to do. And we have various partners. If you go to AWS Marketplace, you'll see our own managed rules and also from several of our partners that you can use and implement. And so those partners are keeping these lists up to date. The next is, again, I mentioned network access control lists. It's keeping in mind what type of traffic is flowing to and from your subnets, right? If you have a web application, there may be very little reason that it should be making outbound requests to a port associated with LDAP, for example, right? Now, one thing to be cautious of here, though, because you mentioned earlier, Jack, there's this tension between, do I fix it right away? Or, in doing so, do I also risk affecting everything else, breaking other things? So there are legitimate use cases for LDAP. And so it's worth considering from the get-go, what do I actually need all of these open ports for? But one control you could certainly have used in Log4j is to block any outbound traffic for ports associated with LDAP if you're not using it, right? And then finally, assuming that you may need something a little bit more permissive, certainly one thing you can always do is check for malicious domains, right? So our DNS resolver firewall maintains a list of known malicious domains. And you can also apply rules like top-level country codes. If there's certain countries the traffic should never be going to. Of course, keep in mind, none of this is perfect because threats are constantly evolving, right? If a domain gets burnt, an attacker may decide to start using a new domain. So not to give a false sense of safety, but these are definitely controls to mitigate many of the more common and opportunistic attacks that we see.
All right.
Jack, I'll pass it back to you for remediation.
Yep, thank you. Once you've implemented the compensating controls in the network, then you need to turn your attention to the software vulnerabilities. Now, these days, 99% of projects use some sort of open source software. Now, this software is chosen by developers to perform certain functions, right? Why recreate the wheel if you can just reuse someone else's wheel? So these are called direct dependencies because the developer specifically chose them and added them to the software project. And as shown here, some of these direct dependencies might use Log4j or whatever else is vulnerable. But direct dependencies sometimes call other open source software. And these add-on packages are called transitive dependencies. And these can also be vulnerable. But the tricky thing is, your developers might not know about these dependencies because he didn't add them to the project. They were added by the direct dependency. So our experience is that the number of vulnerabilities caused by transitive dependencies frequently outnumber the vulnerabilities caused by direct dependencies. So the takeaway is when you're trying to find and fix all your vulnerabilities, you need to use some tools that can show you all your vulnerabilities, both the direct and the transitive vulnerabilities. Now, in the case of Log4j, there were a number of good tools that were available on the internet, including 2 free tools that WhiteSource provided. You can find links to them on our website if you still need them. Now, I've been talking a lot about open source software, and part of that is because our example that we're looking at today, Log4j, is open source software. But there are a few other reasons why open source software security is so important. So I just want to cover them real quick. Reason number 1 is because the use of open source software has been skyrocketing. Today, on average, if you look at what's inside applications, you're going to find that about 75% of the content of a modern application is open source software. Reason number 2 is because the number of vulnerabilities that are discovered every year has been skyrocketing. Now, this is mainly a reflection of the growing use of open source software. There's really more eyes looking at it than ever before. And reason number 3 is basically attackers' behavior. The application has become the attacker's favorite attack surface. This is some research from a survey conducted by Ponemon Institute. We published it a year ago. We hired them to conduct this research. And it found that chief information security officers were most concerned about attacks on their applications. We conducted this research back in 2015 and again in 2020. And as you can see, over that 5-year period, the concern about hacks to insecure applications grew even further. So I mentioned earlier that software composition analysis is the name of the technique that can be used to produce a software bill of materials, but I didn't really say anything more about it. So I just want to quickly explain what software composition analysis does. As shown here, it's really sort of 4 steps. First, it identifies what's in your application. And there's a number of different techniques it can use. The most common is to just scan the application manifest. Then it compares what's in your application to a vulnerability database and to a license database. We've talked a lot about vulnerabilities on this webcast so far, but licensing is also important if you want to keep out of legal trouble. Every open source package comes with a license. It might give you fairly free permission to use it, it might be very restrictive, and you need to know the difference, and software composition analysis does that. Of course, it needs to display results and produce reports like an SBOM report, and it also helps you remediate the vulnerabilities. It works with your developers to do that. Now, a real interesting question is, who owns the day-to-day responsibility for security? Traditionally, the answer was pretty clear. It was the security team, but over time, responsibilities have been changing. And we conducted this research a year ago and found that 71% of respondents said that ownership lies somewhere on the software development side, whether it's the DevOps team or the developers or the team leaders. So with this as a backdrop, Aaron and I thought it might be fun to conduct a quick poll right now of our live audience. Well, thank you, Cody. Here is the poll on your screen right now. Let us know who owns the day-to-day operational responsibility for application security in your organization. And while we're waiting for the results to come in, another interesting question is, who purchases application security? And what we've been seeing is that in more than half of the cases, the security team still has the budget, still has the responsibility for selecting the right security tool. But since the developers and the DevOps people are really going to be using the security tool and deploying the security tool, then the security team really needs to check with these other teams who are going to operate it to ensure that they're purchasing the right tool, one that's quick and easy and efficient to use. Cody, can you show us the results from our poll, please? Cody?
The results should be on the screen.
All right, I am not seeing them.
So we are seeing DevOps or operations at 53%, 50%, and security team coming in second at close to 40%.
Okay, cool. I had to press a button. That's why I couldn't see it.
Sure.
All right, very good. Very interesting results. Thank you all very much. So let's finish up with the last step of a good game plan. Aaron, finish us up.
Sounds good. Thank you for that. So finally, we've considered what we can do to prepare in advance, right? Understanding our environment, putting some basic controls in place. Then we've also considered what additional steps do we take as new information becomes available once a vulnerability is released. And finally, I had mentioned it's important to prepare for an incident as well, right? To assume maybe we didn't get the vulnerability in time, and also maybe the controls that we had prepared for didn't anticipate a certain type of attack. So there's still many things that you can do to control and contain the scope of impact in case of exploitation. First two things I'd recommend is to have, in order to get this information, you need logs, right? So you need data from your environment about what's happening. And so if you're running WAF, for example, you will want to log web ACL traffic. And this will give you a very good insight into what types of things are being blocked, right? Then using GuardDuty, for example, you can detect very specific types of behavior, such as EC2 backdooring. These are under the C2C controls in GuardDuty. So you'll be able to see behavior in an EC2 instance that looks like a C2C compromise, right? Reaching out to an external server, and that would indicate that it's possible a shell was created. You also want to log traffic leaving your VPC, right? If you have a kind of normal flow of traffic and you're only making outbound requests for patching or APIs that your application uses, and then you suddenly see a deviation in that traffic going to these unknown origins, these logs are where you would find it. Back to GuardDuty, also, you don't just want to consider the outside edge, right, of this interaction between the application and the internet. You also want to look what happens if it starts moving inwards. So that's where detecting unusual internal activity, right? Enumeration of resources or resources that don't usually talk to each other suddenly trying to communicate. That would be a good step there. And then finally, these are a lot of different controls, lots of different sources of information. One of the whole points of mitigating risk is simplifying things, right? You want to just have one way to see everything. And that's where sending your findings to Security Hub, consolidating everything in one place, is going to help you detect abnormalities throughout the environment. And then finally, if you define a certain threshold, if you say, look, any suspicious activity with EC2, any enumeration, I want a text message sent to the CISO right away. You can set up those alerts in Security Hub as well, and use services like SNS to send messages. So that is the full comprehensive set that I can cover now. But yeah, one thing to keep in mind, even if you've got excellent defenses in advance, even if you have all your mitigations ready to go, you still want to assume the possibility of these things. You never want to leave a stone unturned. So that's why I would still recommend this. So calls to action, right? Jack and I each have some recommendations following today's discussion. On my end, for the AWS end, right, to get a really good understanding of your environment and whether you have the controls in place, I would suggest scheduling a well-architected review with your solutions architect. And since that review is fairly comprehensive, you can focus specifically on the security pillar if you want to look at some of the network controls that we discussed today. And also, although this is certainly a lens within well-architected, you want to create an incident runbook, right? So for very high-level things like what happens if my AWS account is compromised? What are the steps I would take? And we have resources available to provide you some examples there as well. It's going to be different for each team, but good place to start. And Jack, I'll pass these other points over to you.
Yeah, thank you. We would recommend that you conduct a review about your organization's dependency hygiene practices. As we discussed earlier, if your dependencies are kept relatively up to date, you're in a much better position to react to a vulnerability announcement. And you might not even need to react at all, because simply having an up-to-date dependency can actually avoid many of the fire drills that you otherwise would need to go through. And then if you don't already have an SBOM for all of your software projects, consider getting them. The US government now requires SBOMs from all of their suppliers, and you have experts such as Jen Easterly of CISA that's strongly recommending this as a best practice. And in case you need links to some of these things, you can download this presentation right now, and the link will be on the PDF as shown here. So that brings us to the end. Aaron and I hope that some of what we've talked about today is going to be helpful to you in your organization. Cody, tell us about the questions that have come in.
Sure, we have received a couple questions. And so I'll also remind our audience that this would be a great time for you to send yours in so we can get to it. We've got plenty of time for them. So our first question reads, how do you implement zero trust solutions with AWS, and what is the role of WhiteSource in it?
Great.
Aaron,
well,
I'll
it would
let you
certainly
start.
yes, it would certainly take another webinar to discuss that in depth. But I would start by saying, something we mentioned earlier is identifying trust boundaries, right? What are all the layers that you have to go through to connect these different resources? So the very first step for zero trust as well is to identify those boundaries. Now, one of my colleagues very recently published a new architecture that will inspect traffic between all resources. So it will create additional routing mechanisms between, say, an application server and a database server. At each step, it will allow you to inspect the requests and ensure that this is the normal type of traffic. So if you search for that, I'm sure that would be insightful. But yeah, definitely a big topic, and it starts with understanding your environment and the trust boundaries. And WhiteSource probably has another angle on that as well.
Yeah, we do have a different angle. The opposite of zero trust is blind trust. You've been using a software library for years. Why not just update to the latest one? In fact, it could be that the latest update to a dependency is malicious. WhiteSource has a free tool called WhiteSource Defend that is in the business of telling you whether any individual library is malicious. Every time, within seconds of a new library being posted, we check it out and have a number of different techniques to discover whether there's anything actually malicious. And we've discovered, I think, 2,300 since this WhiteSource Defend was first released. We've discovered 2,300 malicious packages. We've reported them. We've had them removed. Removing them sometimes takes hours or days. It's not under our control. If you had the Defend plugin, if all your developers were using Defend, then they would immediately know whenever they're attempting to update whether some maliciousness has been added.
Awesome. Thank you so much. Our next question reads, what should you prioritize, preparing in advance or mitigating a disaster as it happens?
Can you do both? A lot depends on how you like to live life. I like to live life prepared. It makes things a lot easier. But once a disaster has happened, I guess you don't have a choice. You just have to, push the emergency button if you know where those buttons are, which, as Aaron said, the easiest ones to push are on the network, and then start, fixing the root cause of the problem.
Yeah, this echoes a comment in chat that says, across the board, as a rule of thumb, if you can prepare in advance, that definitely beats mitigating it as it happens. A little nuance I would add there, though, is that there are certain elements that you can only know, say, once a vulnerability is announced, right? You can't patch something if you don't know it exists. And likewise, there is a need to still prepare for events where, like, an external facing resource may get compromised. So I certainly wouldn't undermine those just-in-time mitigations or think that preparing in advance is a silver bullet. You certainly get a higher return on investment for preparing in advance, right? It's a lot less expensive when architecting to think about these things first and then build them. And likewise, it's a lot less stressful. As I think Jack implied, you definitely don't want to be turning on WAF for the very first time when you hear about a vulnerability, although that does happen, right? And it's okay if that had to be, what it took. But one thing definitely to keep in mind is that you still want to have a plan for mitigating a disaster, as it's in play. You still want that to be a possibility on your horizon. So good question, yeah, for sure.
So our next question reads, does WhiteSource provide SBOM capabilities?
That's an easy one. Yes, it does. It's just a basic part of the functionality of our software composition analysis.
And there was a follow-up. So what is the format of an SBOM?
Okay, well, SPDX is the most common because it's required by the US government. Other formats include something called Cyclone DX and SWID, or Software ID. But it's really only SPDX and Cyclone DX should be considered true SBOM formats. SWID was developed really as a software identifier, and that's its primary use.
All right, it looks like we've got 2 more questions. So if you have any more questions, please send them in. We do have time to get to them. Our next question reads, how would an AWS customer test or purchase WhiteSource?
Well, if you wish to, you can purchase WhiteSource through the AWS marketplace. In terms of testing it, contact us. We're happy to help you plan a test and conduct a proof of concept.
Awesome. And looks like one more technical question, but it says, where would you get updated WAF rule sets or WAF rule sets?
Sure. So I mentioned earlier that on AWS Marketplace, there's a listing. We have AWS offers its own managed rules, which are a good place to start. But we also partner with several other security companies that will constantly keep their lists up to date. And you can discover all of those in the marketplace as well.
Perfect. So I'll go ahead and give our audience another minute or two to send in any questions, and I'll quickly give away a couple of gift cards. So quickly, we do have 4 gift cards to give away. These for $25 Amazon gift cards. Our first winner is live drawing, Jane C. Our second winner is Tom T. Our third winner is Peter S. And our fourth and final winner is Karen P. So congratulations. Keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. And I'd also like to take this opportunity to remind our audience that the session was recorded. You can rewatch. The on-demand recording will be made available shortly after we conclude our webinar today. So I'm not seeing any more questions submitted over the last 2 minutes. So I'll give you guys the floor one more time so we can close out.
I think we've said it all.
Yep. Just want to thank everyone for joining us today.
Yes, thank you very much.
Well, Aaron and Jack, thank you so much for taking the time to put together this presentation and sharing your expertise with us. I'd like to thank WhiteSource for sponsoring today's webinar. And my final thanks, as always, goes to you, our audience. We appreciate you being here with us today. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future TechStrong Learning event.
Bye-bye.